and welcome to the Building Sociology Potty, where we talk about better buildings to live and breathe in. My name is Jess Kismet, and I am your host. Today, we have another building science rockstar on our hands. Today's guest is legendary in the building science game, not just for his brains, but his boots on the ground and knee-deep in mud approach to building forensics. Kohta Ueno is the principal at Building Science Corp in Massachusetts, where he spent over 25 years diagnosing why buildings fail and how to make them succeed. A protege of one of the industry greats, John Straub, Kohta brings both academic rigor and forensic intuition to the field. So I am very pleased to welcome you to the show, Kohta.
So much, Jess. Great to be here.
So you started with material science at MIT as your undergrad, is that correct? And
That's
then
right.
you did your master's at the University of Waterloo. So this is a fairly robust education. Tell me about how this education made you the building scientist you are today, and how this makes your approach different to us mere mortals.
I do not make any great claims. I just keep on showing up and getting the work done on the scale of things. So, dredging back to ancient history of undergraduate time, MIT is a thorough meat grinder of a school. It's just been described as trying to drink water from a fire hose in terms of the information flow. So, pretty brutal. I would argue that part of how my MIT education directed me into this field is by completely burning me out during my undergraduate career, and basically never making me want to do another equation ever again, frankly. So basically, when I graduated, I realized what I really loved during my off time during undergrad was fixing things around the house. I ended up hanging up my shingle as a carpenter doing small carpentry and remodeling and bathroom renovation jobs. Incredibly useful and interesting. And unfortunately, I'm a terrible businessman, so I ended up living in my parents' basement after a few years. Fast forward through that, and I was watching an episode of Nova. It's a public television science show in the US. And my mentor, Joe Lstiburek, was actually one of the talking heads on that program, where basically he was describing how he diagnosed the indoor air quality problems at the motor vehicles building where people were having scratchy eyes and noses. And he was the one who figured out the air leakage problem coming into the suspended ceiling that was dropping debris and causing all of those sick building syndrome problems. So I cold called them, and that incredibly luckily, they were looking for an entry-level person right there and then. So basically, my academic education, the burnout aspect kind of brought me into this field by a very roundabout method. When people ask me, do I use my undergraduate knowledge? Not specifically. So, I concentrated in material science on, metallurgy, the metallurgy side of things. And so they say like, oh, here's a corrosion problem. Can you help me with that? And my answer is, honestly, you can read a corrosion table as well as I can. What's the potential difference between these? That's what you really need to know.
So I think, I'm not sure, I didn't use my undergrad either. And I reckon when you go to university or college, the undergrad is like, it's kind of just teaching you about how to learn most, like, unless you do it like you're a doctor or an accountant, and that's going to lead to a pathway. I find that it's just a bit of a way to like allow you to grow up a little bit, clearly, stretch the brain and, teach you a little bit about life, not just the topic that you're actually there to study.
Completely agreed.
Yeah.
Learning how to think, how to solve problems, all of those aspects, as well as being socialized into a greater sphere than many of us had very, channeled childhoods, I'll say.
Yeah.
Opened up the direct aspect for sure.
Yeah, teaching a bit of independent learning and things like that.
Yeah, and as a big picture point, it seems like so many people in the building science field followed some kind of a strange meandering path to get here. Like unlike the people who are, people who have a very distinct career path, majoring in biology during school and then pre-med and then going to med school, becoming a doctor, going all through that. More power to all the people who have that kind of a career path in mind, but that describes very few building scientists that I know.
You're 100% right, because it's not a career path, is it? It's not a degree that you can take and think of as a kid at uni. You don't go to the careers counselor and they say, how about you talk about mold and building failures? Like, that's not a career path. We all get here kind of by happy accident because we realize through our other ventures, oh, there's a real problem here. I want to know more about this. So, on that topic, when you talk about teaching people how to look at a house like a building scientist, so how do we do that? What's the first thing that you look for? How can we teach other people to look at buildings like a building scientist?
Background, I wrote that multi-part series on Green Building Advisor, and it's been published in a few spots on that's called How to Look at a House Like a Building Scientist.
Hmm.
And I'm concentrating on teaching the tools that I use, just because there are plenty of things in an investigation that you cannot see. But that kind of shortchanges people a little bit, concentrating on just the tools themselves, because there's a whole level of building diagnostic thinking through the problem that you need to understand first. So, big picture wise, figuring out what is the problem, gathering the information on the problem, those are a couple of key things. Joe Lstiburek was very fond of telling anybody who he was a mentor for, talk to the people on site, talk to the people who've been living with the problem for a long time. They might not know the science behind it, but they can tell you the patterns. The guy who is mopping up all of the drips that are coming from the ceiling, he's got not going to be able to tell you the whole story of the problem, but he will have some vital clues in there. These are occurring on the day that it rains, or it occurs, 2 days after the rain, or it has nothing to do with that. It's only happening in the spring. Each of those are completely different problems, from rain leakage to stored moisture to condensation issues, that you would need to wrap your head around in those various cases. Another way to think in this type of investigation and investigatory mode is looking at the patterns. Are the problems only occurring on the east side, the south side, all of those types of aspects?
Hmm.
Occurring on all stories and all conditions, or are they limited to, like, there's a weird thing going on where I'm only seeing drip marks in these patterns? Just as a really odd example of, looking at patterns in general, I was once wandering through a building where it was basically a asbestos hazardous material remediation gone completely wrong. They tried to mask off the moisture sensitive surfaces with plastic and hit the inside with a pressure washer, which was mistake number one if you're trying to work on asbestos. They ended up flooding part of the building, having it flood down through the floors. Basically, they turned an asbestos remediation job into a rip out all of the drywall and fix the mold job.
Hmm.
But walking around, I saw these really strange stripe and dot patterns, and that frankly was just a small, like a micro lesson, that the stripes that were not growing mold is where the drywall was taped at the seams, and the dots were where they basically covered the screw heads.
Hmm.
And that was demonstrating that paper is ideal mold food, and even the thinnest of 16th of an inch covering of joint compound could be enough to reduce how much mold will grow there. As Joe was very fond of saying, even the dumbest of the three little pigs didn't build his house out of paper.
So, is that because the moisture was on the other side coming through? Or was it did
Sorry,
it
this
just
was
create
no,
a different
basically
property?
it's all of this was surface moisture on the basically the interior surface that you're looking at.
Oh.
Everything got really wet and, was unable to dry sufficiently quickly. And as a result, and so basically grew on the paper surfaces, or the painted paper surfaces, excuse me. But just that thin skim of drywall was enough to basically separate away the paper to reduce how much mold grew at each of those stripes, for instance.
Yeah, right. Interesting.
Yeah.
Interesting.
Yeah, but in terms of, like, other things for figuring out the diagnostic, how to think through the problem is, you know, con you know, there's a little bit of scientific method there of, what's the hypothesis that you're putting together in your brain of what the cause would be, and then you're constantly looking for, okay, this is going to be either inconsistent with my hypothesis or actually actively refute it. So,
Mhm.
keeping your brain open where it's like, this is my pet theory, but I'm willing for this pet theory to die if I'm seeing information to the contrary.
Yeah, I think one of the themes that comes up again and again in my conversations is stay curious, always question your assumptions, keep an open mind. Because, yeah, buildings can surprise us.
Yeah, absolutely. Just like one surprise was walking around on an investigation and somebody pointed out, like, yeah, check out all of this efflorescence staining on the side of the school building. And then the school facilities guide said, like, well, actually, that's the corner around the side door where they bang out the chalk erasers. It's like, duh, you got me.
Classic, classic. Back in the day, huh? When we had chalkboards and
Yeah, yeah, the not whiteboards.
the nostalgia that brings back.
Yeah.
Oh, that's funny. Have you had any other surprises? Any other buildings where they, didn't quite tell you what they thought they were going to?
There
Anything
was
you can think
one,
of?
like, so just as background, my primary focus is energy, moisture. That's kind of the fundamental of building science. But the
Uh-huh.
hardest problems to diagnose in general are odor problems. I don't know if you've
Mm.
had any guests talk to you about that, but one very big problem is they are often intermittent and they're often very subjective.
Yeah.
I've walked into one building with odor complaints where I've had some people say like, "Oh, it smells like somebody's heating up leftovers in the break room." Like, "No, it smells like bananas." What am I supposed
What am I looking for here? Come on.
Yeah. And of course, another problem with odors is that just the human senses, you go nose blind, where basically if you're in the environment where that odor is prevalent, you're not going to smell it after,
Stop
10
smelling
to
it.
15 minutes.
Yep.
The reason why, pig farmers can, continue doing what they're doing, like, what smell? Yeah, but a surprise happened during an odor investigation was I thought that I nailed the problem by, basically proving that this makeup air system for a kitchen exhaust had failed. Therefore, this massive negative pressure that was pulling in odors from the source was, we've, fixed the fan and the problem has gone away. A couple of weeks later, the problem still pops up again.
Hmm.
Um, that and you're like, what the heck is going on? And I literally ended up finding the problem by standing around with up on a ladder in the suspended ceiling where I think the odor is coming from based on my pressure mapping. And then I start to smell the odor when somebody flushes a toilet by sheer luck. And it turned out that there was a crack on the top of a drain pipe. So there was no water leak, but every time somebody flushed a toilet, that pushed out a plug of foul smelling air that then got sucked in to that contamination source. Yeah.
Wow. Yeah, well done finding that one.
That was very lucky, frankly.
Yeah, just timing. And that's the other thing, isn't it, too? Sometimes things can just, if you don't know what you're looking for, sometimes you do just have to get lucky.
Absolutely.
Just in that exact example was, yeah, interest. That's fascinating. Okay, so retrofitting mass walls.
Yes.
In Australia, there's a lot of that going on right now. People are retrofitting double brick walls. They're retrofitting, cottages that are made of stone and things like this, heritage masonry buildings. They want to keep the beautiful history in these homes, but they want to make them more comfortable because they're typically not very thermally comfortable. So, what is the safest way to insulate a mass wall, both double brick and a single leaf masonry wall?
Yes. So just to clarify what we're talking about here for your audience, when I think of mass masonry walls, at least in the North American context, I'm
Hmm.
thinking of solid multi-layer brick walls, typically in New England or the Midwest of the United States. We're talking three or more layers, three or more widths of brick, the classic mill building, university building, those kinds of things. What you're describing for Australian construction, it
Like,
sounds like two width is more common for residential. Is that what you're saying? Yeah.
yeah, we don't have three leaf brick walls. We have double brick and occasionally like Besser block, like heavy block walls.
Okay. Gotcha. Gotcha.
Yeah.
So, so once again, to talk through background to make sure we're all talking about the same thing.
Hmm.
Mass masonry walls have no actual water control layer or drainage plane or water resistant barrier. I don't know what the Australian term might be.
Hmm. Yeah, similar. We're with you so
Okay.
far.
Yeah, so basically the way that they work is when it rains, basically the moisture hits the surface of the brick or block, it soaks into it, and then later on over during more favorable conditions, those during dry conditions, the moisture evaporates outward back through. But during that intervening period, the moisture is stored safely within the brick or the block without any damage. You can put a brick in a bucket of water and it won't get damaged. To a stud wall with OSB sheathing, it's going to go south on you. So
Hmm.
that's the fundamental way that they work. So part of the secret of how they work is the thickness relative to the amount of rain. So that's kind of why I'm used to seeing a triple white wall as basically historically in New England, they figured out go 3, 4 brick layers of brick. That's enough so that during the worst rainstorms that they see in New England, you probably won't see dripping come from the inside. Because brick walls are porous to water, anybody who has stood on the inside of a single white brick veneer during a spray test will tell you that you start to see little drips of water coming through within 2, 3, 5 minutes, something like that. So each of
Okay.
those layers porous to water, but you combine enough of them, they'll soak it up and keep that from actually dripping to the inside. A whole lot of background before even talking about the insulation problem.
Hmm.
So, when you insulate one of these walls, you always have the choice of going on the outside or the inside. The outside is always going to be safer, full stop. And whenever I am dealing with a ugly 70s building that people want to retrofit with insulation, that is a mass brick or masonry wall, I tell them like wrap it with exterior insulation, synthetic stucco, panel job, something along those lines. That's always going to be better in terms of thermal performance and moisture safety. But then again, you go to a lot of historic buildings, and these are beautiful resources that are part of the fabric of the town. The facade is incredibly critical. So, there's no way that anybody could you know, consider destroying that type of facade and covering it up with something significantly less decorative. It would be a solectomy on a building along those lines in a lot of cases. So you can insulate on the inside of the building. The problem is that when you insulate on the inside in a heating dominated climate like New England, the Midwest, the North in the United States, you are reducing how much heat is flowing through that wall, which is great for your energy use, and bad for drying ability. Remember that because this wall relies on drying out later on, if you've reduced how much heat flows through it, you've reduced how much it can dry.
Hmm.
So, therefore, what you want to do if you're even considering insulating one of these mass masonry walls is you want to look very carefully on, is this wall getting wet, significantly wet, and address that before even considering doing interior retrofit insulation.
Hmm.
Disconnected downspouts, roof wall intersections that's pouring water onto the wall, splashback at the ground, bad drip edges or parapets. All of these things can dump disproportionate amounts of water on the wall. And
Hmm.
you should basically I have people arguing about what are the various insulation options on the inside, and I tell them stop, stop, stop. Before you're even thinking about this, deal with the water on the outside, then we can start to have that conversation of how to do the interior insulation.
So we're not just worrying about rain, we're worrying about, like you said, like drainage off the house, down pipes, eave depth, or overhang depth, all those sorts of things as well.
Absolutely. Anything that concentrates water and sends it on the house, or
Mm.
grade contact conditions. If the ground is wet and you're wicking water up through your brick, I've seen
Hmm.
plenty of cases of damage, as well as just to kick out another potential damage mechanism. There's snow and de-icing salts in much of the Northeast, where people cover their sidewalks with salt to melt the snow and keep people from slipping and falling. That can cause a massive amount of damage to bricks and stone in a short amount of time, causing, once again, a whole lot of damage.
Mm.
That's yet another mechanism to worry about.
Interesting.
Yeah.
We don't have that problem in most of Australia. We don't have snow and ice, except for, up in the mountains in New South Wales and places like that. But that's an interesting unintended consequence, isn't it? Melting the snow with salt, but salt absorbs moisture, so it's going to sit there and then wick up into the bricks. Is that what happens? Yeah,
Yeah,
wow.
basically, there are basically the salt causes strange osmotic pressures going on, and I have seen cases where the entire, outer half to 3/4 inch of the brick has basically fallen off, where the truck has come by with de-icing salts every winter, and, it's just degraded it all over time.
You gotta ring up the council's coder and be like,
Yeah.
"My dude, you're making a mistake."
Yeah, you're destroying your wall, if, just so you know.
Yeah, yeah. Just so
Yeah,
you
so,
know.
like, I have to couch some of my recommendations with a few caveats that, like, I'm coming from a Northeast cold weather perspective.
Yeah.
If it's a lot milder of a climate, a lot of these fundamental problems are reduced. Like, the classic thing that I'm looking for mass masonry buildings is, are we going to make freeze thaw issues worse? Where basically you see the surface of the brick popping off. And
Mm,
there's, is a potential risk of that once you insulate on the inside. The brick is colder. The idea, though, is for freeze thaw to happen, you need the brick to get very cold. We're talking sub 20 degrees Fahrenheit, in the 20-degree Fahrenheit range, up and down, well below the freezing point, as well as having the surface be wet, very wet. We're talking soak it in a bucket wet. And that would cause freeze thaw. But, if you don't have many freezing cases in Australia, freeze thaw is no longer an issue at all.
It's time for a quick sponsor shout out. Today's episode of the Building Sciology Potty is proudly brought to you by our amazing sponsors, Enduro Builders and Climasure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages.
no, I mean, we have we do have some frost issues even in Adelaide in the winter. We can get below zero, not usually not two below zero, like at 0 -1 Celsius. So around about, I don't know, 25 degrees maybe Fahrenheit at a guess. Um 30 degrees. What was I going to say? We do have in parts of Australia we have not so much frost but humidity issues. So I guess I did a woofie assessment last year for a client who was wanting to insulate. It was a brick veneer, so brick leaf timber stud construction. It was uninsulated, and he's like, "If I insulate this, am I going to cause a huge problem?" And woofie just threw it in the bin. It was like, "This is terrible. You can't do this. You can't put insulation in the stud." Because of all the humidity that was in the air and in the cavity, it was just basically saying there's just too much moisture here and something's going to go moldy. So what do you say to that?
Yeah, that sounds like a very strange outcome to me, just given that I think of a brick cavity wall, well, a stud frame wall with a brick
Mm,
veneer and an airspace to be,
quite
a
resilient.
pretty known quantity. And,
Mm,
insulating that is pretty much an off the shelf solution overall.
mm.
Not to bore your audience with the nerdery, but just curious what
No,
you were
please
using
do.
for,
That's why we're here.
okay, like ventilation terms inside the brick air cavity, that kind of thing.
Yeah. Yeah, there was a lot of variables, but basically it was just telling me that there's a relative humidity, an average relative humidity throughout the year of 70% plus. And it was just not happy. The bricks were, pushing moisture into the wall when the sun came up, moisture, because we couldn't get a membrane on there because it was a retrofit. And the
Okay.
solution ended up being coating the bricks with like I think it was it was a
Solid
render
say.
product.
Yep, reducing
So
the absorption of the brick.
that's
Yeah.
correct. That's correct. That seemed to fix the problem. So the problem was obviously coming from outside, and there was a lot of moisture held in those bricks. So is that if we're internally insulating, and this goes for, I guess, warm, humid climates as well as cool climates, the answer is probably going to change. But if we're talking about rain on bricks and they're very porous material, they absorb a lot of moisture. Um, is sealing the outside of a brick wall or a mass wall in a retrofit a good idea to stop the water getting into it, or?
Yeah, I'm sorry, I'm gonna have to give the classic engineer answer of it depends, and I can't
Yep,
say for sure. So,
yep.
Joe Lstiburek has a delightful article called How Buildings Age, of basically showing the evolution of buildings where, hey, it's a brick building and with leaks all the time. So
Mhm.
historically, painted them. People have put on a stucco render, and that definitely does reduce rainwater absorption. but there are definitely are there cases where you paint a building and all of a sudden it starts blistering all over the place? Yep, those
Mm.
cases also do occur. You can try to counteract that by having a more vapor open paint, which might or might not be enough. So if the question might be if water is getting in somewhere else and trying to work its way out, it's a recipe for problems. I dealt with a case where New York State, they recently recoated their masonry building with another coat of a breathable coating. And all of a sudden, they started getting these giant blisters filled with white minerals. When you peeled back the blister, you could basically scoop out little bits of mineral staining.
Hmm.
So the reality was, did the coating reduce how much water got through the wall, the face of the wall? Yes, absolutely. Was this coating breathable, as in allowing some drying? Yes. However, they were letting too much water in at the top of the wall, which worked its way down
Mm.
it. And, once again, looking at the patterns, where are the
Hmm.
blisters fall along those parapets? So
Hmm.
basically, water is getting in through the top and the parapet walls, you know, trying to work its way out. And basically, it's only so breathable, is what I would say about the
Yeah.
coating. You can release so much moisture before it starts to blister and blow off on you.
Yeah.
Yeah.
Buildings will surprise you.
Yep. Yeah, and returning to a previous topic where you're talking about inward vapor drives, that absolutely is part of the problem. So basically, the way that I always describe it is think of a brick as a very dense sponge on the outside of your building. And you go ahead and heat it up and, put that wet brick in the sun, moisture will blast off both inward and outward. Inward is the direction that we're always worried about. The thing is, I typically only see problems with that when there's something that's completely stopping that moisture moving through the wall, that inward vapor drive through the wall. For instance, a recipe for disaster is brick veneer, airspace, a super vapor open sheathing in the US, it's a historic product called wood fiberboard. I don't know if there's a similar one in Australia. Insulated stud wall and a plastic vapor barrier on the inside. Um, I don't know if you've ever seen those survival stills where you have a sheet of plastic trying to capture evaporated water,
Mm.
but basically you've built one inside of your wall, is how I would
Yep.
describe that assembly. And basically a builder in Ohio went completely bankrupt by building their walls that way. Takeaway is inward vapor drive happens. It happens because there's an impermeable layer in that sandwich that's stopping the water. So it could be a dumb polyethylene vapor barrier. It could be if your client decided to put floor to ceiling mirrors on their home gym, for instance. Glass is a
Mm.
perfect. It could happen where you have an art collection and you have glass-faced photos on the wall or cabinets with melamine impermeable backing. Those are all possibilities. But typically, if your interior side of your wall is vapor open enough, you should be able to dry that inward. The way that I describe it is the catastrophic flood is not caused by the river flowing through it. It's caused by damming up the river first.
So what if the internal plasterboard or drywall is painted with something not impermeable?
Yeah, at that point, like an oil-based paint on the inside of plasterboard, that's an edge case I've never modeled myself, but it does not bode well, is how I would put it.
Mm. Okay. So what about putting insulation in the cavity of a double brick wall
Yeah,
in the middle?
so sorry, let me make sure I understand. This is two brick walls separated by an airspace. Is that what we're talking
Yes.
about?
Yes.
Okay,
So a
I'm
lot of the
sorry.
1960s, 70s homes have been built with 2 leaves of brick, and then people who move
Yes.
into them think, well, we'll just blow some insulation into the cavity to make it more comfortable.
Yeah, I
What's
would
your comment on
not.
that?
Yeah, that would make me nervous in general.
Mm.
Once again, a Joe Lstiburek column where he basically cites Vitruvius from, 2000 years ago, stating how do you keep brick walls dry? You build two of them and you put an airspace in between them because basically that outer leaf is porous to rainwater like we described, and we're letting the water penetrate through, drip down, and come inside. And if you infill that cavity with insulation, you've basically slushed it solid and removed that drainable air cavity. I
Mm.
wouldn't I do not have enough experience with these to say, oh my God, it's an automatic failure, but it definitely makes me nervous. And I
Mm,
have a specific case study in mind where there were a school building, once again, solid brick, but with an airspace somewhere in that sandwich. Top floor was leaking water because, through the walls because that's where the majority of the rain hits. And the people in that school district said, well, we have this air cavity. Let's go ahead and pump that full of, cementitious grout, and that'll stop the water. And surprise, surprise, the problem just ended up getting worse and moving to other spots instead.
yeah.
So that's that was my instructional background case of the problems that can be caused by that.
Yeah, it's definitely a question I get asked semi-regularly. So to summarize this, external insulation is best. It's often not
Yes,
possible though, because people have facades they want to keep, or it's just
absolutely.
tricky. Finally, good idea, but take care of the water on the outside as a priority.
Absolutely.
Middle of the cavity, probably don't do that.
If somebody has more of a track record than me on this, I'd love to know their experience, but it
Hmm.
does not give me a warm fuzzy.
Even in cold climate, warm climate, humid climate, all of it,
Yeah, anywhere that it rains.
yeah.
Okay, if you're building this in Los Angeles or Phoenix, frankly, you can get away with anything in terms of rain control. I've gotten asked to review buildings in Los Angeles, and my response is like, why do you care about rain? It never rains here. Basically,
Okay.
problems are caused primarily by Los Angeles architects doing work in other climate zones and not adapting accordingly.
Interesting. I did not know that. I did not know that Los Angeles and Phoenix don't get much rain.
Yeah, basically, those
Totally
are the
different.
desert portions of the United States.
Makes sense. Yeah, those architects would not be well versed at all in the kinds of moisture issues. So that's interesting.
Or they've probably worked within an ecosystem where they can get away with many
Mm,
things that are not possible in other rainier climate zones. And also,
yeah.
I'm probably being a little bit facetious in terms of the broadness of the brush, just because absolutely are levels of knowledge here that
Of course.
there are ones who do know the risks they are getting into for sure.
Of course. Of course.
And just to wrap up the last piece of this, when we're talking about insulating a solid mass masonry wall, our recommendations in any climate that has cold weather condensation risks is you want to have something that keeps that interior air away from the cold masonry surface. New England using spray foam or rigid foam on the interior of the masonry is a pretty common solution. There are options of doing it with fibrous insulations like cellulose or mineral fiber, but you have to be a lot cagey and a lot more concerned about how good your interior air barrier is and how well it controls that movement of interior air. The other beauty of closed cell spray foam and rigid foam boards is that, for every for the 10-year period between massive hurricanes hitting your building, you're not going to see any water coming through that wall. But you have a massive storm that has little trickles of water coming through your mass masonry wall. At that point, you'd prefer to have a material that is not sensitive to water. And in that case, the rigid foam board or the spray foam both have lower risks in terms of, will this grow anything? Nope. Will it be degraded by water? Nope. So that's
Hmm.
kind of the reason behind that being the go-to solution.
So there's a bit of a way up process, I think, when it comes to choosing insulation, or at least in my mind. That's why I'm asking you. So from a non-water sensitive material like a foam, we don't use spray foam in Australia very often. We usually use rigid boards, and that is a common go-to for insulating internally on masonry walls. Or we would use something like a wood fiber board, which is more vapor permeable. And that it's a question, which one's better? Which one would be better? Or a rock wool, that's not water sensitive, but it's also vapor permeable. So would that be like,
Yeah, all of these solutions can work. Like, I'm thinking of the pros and the cons, kind of walking through those three different materials.
mm,
Both the rigid foam and the rock wool, the semi-rigid rock wool, have the advantages of having a little bit more resistance to water. A
Mm.
wood fiber board, depending on the type of product, whether it's wax treated, might shed the water or might become a little bit funky for sure. In
Mm.
terms of vapor permeance, you absolutely agreed. You have the advantage goes to the non-foam options at those points.
Mm.
Frankly, thinking through the problem and making sure you understand it holistically is very important. I once dealt with a existing mass masonry building, Massachusetts, where they insisted on using open cell spray foam, the vapor permeable version of spray foam, on the inside of the existing brick and block wall because they were insisting that we need to have inward drying. I got to the site and I realized that the entire inside of that wall is covered with a black asphalt coating.
Redundant.
We lost that battle back in 1925, and apparently this wall has been just fine without inward drying all that time.
Right. Okay. That other comment you made about the cool surface of the masonry, I guess this is something that it's a question that comes up when we talk about insulating the internal side of a brick wall. What's the risk there? Like, we know when you're putting rigid foam up, for example, how important is it to tape the joints, make sure that no air is getting to that internal surface of that mass wall?
Yeah, so in a cold climate where there's a condensation risk, that's absolutely vital in terms of
Hmm.
preventing condensation at that interface between your masonry wall and your rigid foam, for instance, or your interior insulation. In warmer climates where there's no condensation risk, possibly not as critical, but the question devolves then to, okay, where's your air barrier? Are you painting on an air water control barrier on the inside of your masonry wall? Or are you
Mm.
relying on that foam as a rigid air barrier material? Because we ought to have an air barrier in here somewhere for sure. And a reality is that unpainted brick masonry is definitely not an air barrier. There's
Mm.
60s Canadian research where they actually went and tested that, and it's 0.25 CFM 50, I think, or something along those lines. It's actually measurable leakage through
Mm.
unpainted brick.
Hmm. So air barrier on the inside before the insulation.
Either air barrier on the masonry before you start your insulation process, or make a air impermeable material like rigid foam into your air barrier
Right.
by
Okay.
taping all
All
those
right.
joints as you. Yeah.
Thank you. I hope we covered that thoroughly enough. All right. Now another complicated topic. I don't know. It's not easy to cover this one in a less than 1 hour podcast. But vented and unvented roofs, pros and cons. Can we summarize
Yes.
this for the audience?
Yeah, for sure. And, once again, I apologize if I might be losing some of your audience, given that I'm North American based and I know
Yeah.
exactly this is a construction that I know. So whenever I start my lecture on attic and roof construction, I tell people if you want a durable, moisture safe, good energy performance a roof system, vented attic where you have basically a triangular space where you're walking around with, you can see the underside of the roof sheathing. You look down and you see insulation down at the attic floor. That is the ultimate for durability and performance, frankly, especially in a cold climate. But that is key. Part of the key is that we have a bulletproof airtight layer, air barrier down at that attic floor. It has not been turned into Swiss cheese by recessed light fixtures, electrical
Hmm.
boxes, speakers, ceilings that pop up and down all over the place, stud walls that are poking through it. All of those have the potential to basically negate an effective air barrier down at your attic floor. But the tendency in North America in many cases is, oh, this is an empty space that we're not using. We are going to put our heating and cooling system, our air handler, furnace, and all of the ductwork up in the unconditioned attic. This is historically done for a very long time and is incredibly dumb. You are putting the most critical portions of your building, your heating and cooling system, in a location that gets screaming hot in summer and freezing cold in winter. So our takeaway is, if you can't convince people to move the space conditioning system out of that screaming hot attic, go ahead and run insulation up at the roof line instead of the attic floor, including that triangle within the conditioned space.
Mm.
And you have basically brought the entire ductwork system into the conditioned space. It's running within a few degrees of interior set point.
Yeah.
The problem is, if you just throw bat insulation up into a roof line, that is a recipe for causing problems. We've done a multiple multi-year studies on this problem. The takeaway is that if you want to do it in North America, at least in a moisture safe and code compliant way, spray foam up against the roof deck is a straightforward, time proven, and workable solution. Is it expensive? Yes. Is it environmentally damaging material? Yes, it is. Would it be nice if there were better methods? Absolutely. But historically, what has ended up working in general is going with some type of a foam solution. There are also solutions where you can put insulation on the top side of a structural deck, similar to a commercial roof where you have layers of foam board with a roof membrane, but that is asking an awful lot for residential contractors in many cases.
Yeah.
So is that, so I'm starting to dial in the problem. Is this the direction you're
Yeah. Yes. What's
dive
happening
into?
just on that insulation
Yeah,
at the roof line topic? It's becoming more and more common in Australia for builders to. We don't
yeah,
have spray foam, like I said, but the builders
yeah.
are they're moving the bats from the ceiling to the top of the rafters of the truss, the top of the roof line. So that is something because of the air conditioning, ducting, and everything. Keeping it inside the thermal envelope is becoming a preferred method. So that's one way that builders in Australia are moving towards sort of better building methodologies. My question is because we have this battle, sort of not battle raging. I guess just a bit of confusion in Australia because in the last building code change, or a couple ago, roof ventilation requirements were introduced for our cooler climates, and we often have a mixture of roof void roofs and skillion roofs, and the ventilation requirements are different.
Sorry, I missed those terms you were describing the two roofs.
Like a roof void, like a truss roof with a roof like
Yes.
an air, but like a triangle type roof, and a skillion, which is more like a cassette roof, so that the roof is raked, the ceiling line is raked, is on an
Okay.
angle for
Okay, sorry, I'd
architectural
not heard that
reasons.
term. Basically, it's a compact assembly where you have ceiling finish, insulation, and
Yeah.
uh, air cavity, something along those lines.
Yeah. Yeah, that's right. So we
Okay,
have all these different ways of, and they're often in the same house because there'll be some, because the roof void design is cheaper than a skill, like a raked angled type cassette type roof. And they'll have like a skillion roof in like a living area, for example, and then the bedrooms will have flat ceilings. So there's this combination of roof types that have different ventilation requirements. And Joe, I had Joe on the podcast back when I very first started. He was one of my first handful of guests, and he threw a
yeah.
bit of a cat amongst the pigeons and said, "Don't vent your roof."
Hmm.
And in Australia, we're all trying to get our heads around how to ventilate our roofs. So I guess my question is based on that statement and the confusion we're currently experiencing here about how to do it. And Joe's statement was actually around fire resilience. But they'd just been the California fires, and we were sort of I think we're having a bit of a discussion about that. And yeah, he made a statement about not venting roofs, and it confused a few people.
Yeah, so specifically to fire, ventilation is basically a burning ember capture device. So
Mm,
that lines up with why you would want to prevent that.
mm,
In general, roof ventilation is a useful tool in the toolbox for colder climates and preventing moisture problems. That is true. Whether it does as much in warmer climates, yes, you can argue that it makes the roof sheathing a little bit colder, but if you have a full layer of insulation below that, it might not really matter on that much on the scale of things.
mhm,
Yeah. We've done, like I said, we've done a bunch of research on removing ventilation in cold climates and some warmer climates. And the thing is, you can still sometimes get edge cases where you run into problems removing ventilation in warmer climates. It could be made up for with various features like what we call a vapor diffusion port, some way to let the roof dry out, as well as trying to, dehumidify the air within that attic. But that's a whole, like, I can pretty much give an hour discussion on that
I
topic
know.
alone, for instance.
You could do a PhD just on roofs.
Absolutely.
There's so much to know
Yeah.
and think about.
Yeah, one of the things to remember about roofs is that, as a big picture thing, is because they face the sun, they are seeing the most energy compared to walls or, even less foundations. Just think about the amount of heat flux going in and out of roof assemblies. And so, we've had problems in North American open cell spray foam roofs where people go up into their attics in those conditions, and they're saying, why is it 70-80% humidity up in this space? And we've ascribed that to what we call ping pong water of moisture being driven out and sucking back into the roof sheathing. And
Mm.
because the roof faces the sky, it sees an incredible amount of sun and solar energy, and that is the force that is blasting out the moisture and causing this type of a ping pong problem. I often refer to roofs as, solar driven moisture concentration machines and all of the problems that can result from that.
Yeah, indeed, indeed. In climates, so in our cooler climate zones, we have 8. So in the coldest 3, we have to vent our roofs. We've been given certain sort of square meters per millimeters per meter openings at the low point and the high point that builders have to achieve when they are building their roofs. Requirement conflicts with sort of what when builders are trying to achieve air tightness on the outside of their structure, it conflicts, and then they get confused about how to do both, and they have to compromise one for the other. And but if we seal up our attic, are we going to get a horrible mold problem? But I want to do this. Yeah. What do you have any feedback on that?
So, like in North America, we refer to a compact assembly where it is interior finish, insulation, air gap with ventilation, structural sheathing, and then your roof cladding. We refer to that commonly as a cathedral roof, a
Yep, we use
vented
that
cathedral
terminology.
roof. Yeah, okay. And basically they work in terms of moisture, in terms of energy, you're taking a hit because you have less space for insulation. And in terms of air tightness, they are not always, but very often absolute disasters because you only have one spot to get your level of air tightness, and that's your interior finish. And once again, if you fill that with recessed light fixtures and other items like that, that is how you have you only have one chance to get it right, unlike a wall
Mm,
where, you have exterior sheathing, interior gypsum board, and between the two, that could work out typically. In case of a vented cathedral roof, one chance to get it right, and if you have a hole through your interior drywall, it is sailing up through your ridge vent out to outside.
mm,
So that's the air tightness problem that we talked about, that you mentioned for sure. There
mm.
are solutions out there, for instance, building a false cavity inboard of that cathedral assembly where you have a continuous layer and then all of your bric-a-brac and your lights and wires and speakers inside a cavity that is inside the air barrier. That is a good solution. Is it more layers? Absolutely.
So there's a company here it's a German company that have distribute their products now in Australia and New Zealand called Proclimer. Don't know if you've heard of Proclimer.
They're European based and they sell in North America through companies like 475.
Yes, yes, of course I do. Of course I do. Yes, I've seen their social media posts. So we have those products here, and they have become a sort of a solution for air tightness issues with that, false ceiling, vapor barrier above the false ceiling, and external membranes as well. The external membranes has been a bit of a game changer in Australia because it creates a continuous layer on the outside of the structure rather than using what we call a roof blanket. You guys don't use them over in America, but they're like a foil-backed bulk insulation that go underneath the roof sheets. And that's supposed to keep the roof sheets warm so they don't condensate and it's supposed to provide a little bit of thermal benefit to the house itself. But on the flip side of that, once you ventilate that roof cavity, then the thermal benefit of that insulation at the roof level is pretty much wiped out, right? There's air
It's
movement underneath
bypassed,
it.
that is true.
Yeah, yeah. So yeah, those external membranes, the membrane systems have changed the way houses are being built in Australia, which is a good thing, but we're still transitioning. So yeah, it causes a bit of confusion about how to achieve it correctly.
But that the classic spot where the detail falls, like I completely agree with exterior air barriers. My go-to in North America, self-adhered vapor permeable membranes.
Mm,
Basically, trying to put an air barrier on the inside is possible, but it's a lot more difficult. It's a lot more work. On the
mm,
exterior, it's a lot simpler to just have a continuous line. You could send your worst employee just to feel the entire building to look for gaps that someone missed, for instance.
yeah,
And they'll probably find anything. The
yeah.
tricky bit was transitioning to a vented attic, for instance. The detail that a bunch of practitioners have done is what I call the bridge membrane, where you basically, before you tilt up your exterior wall, you'll have a little flap of membrane over the top of your wall top plate, and
Hmm.
that basically passes your exterior air barrier to the inside of your ceiling.
Yeah. Yeah, we call that connection strips.
Okay,
So,
yep, there you go.
yeah. Yeah, yeah. But again, a lot of builders don't know about connection strips. They don't know about air barriers. They don't know about continuity. They don't know about these things. So this is something that we talk about and try to encourage. And it changes the way the frame goes up. It changes a lot of things about the sequencing of a project as well. So it's a big shift, but it's happening amongst some Australian builders, and it is great to see.
Yeah,
Okay,
training a
I'm not.
workforce is always a challenge.
Pardon?
Yeah, training a workforce is always a challenge, especially in new techniques. Absolutely.
Yeah, it is, but it's very fulfilling. And once the builders understand um, that there is a better way to do such and such, they're usually really on board and they're usually really, really keen. So it's a quite a fulfilling space to be.
Absolutely. And also, builders are smart. They're trying to figure out the problem. And
Yeah.
if you give them the proper tools to feedback, they will come up with a better solution than you, is what I found.
Exactly. Yeah, exactly. It's fantastic. I don't know if we could really talk a lot more about roofs. We could go a lot more into depth about it, but we won't today. I hope that discussion made enough sense for the people listening. I hope that they took something away from that. So we'll move on to the next question. You use a lot of diagnostic tools in your work. A lot of different equipment. What's your favorite? What's your kit consist of, and what's your favorite?
The kit that I bring to most of my investigations, a camera, an infrared camera, moisture meters of various sources, various types, little water squirt bottles if I need to inject water at one specific point to see if it comes out later. Some minor disassembly tools just so I can, pop out an outlet or to look behind the wall, see what I can see behind the wall, or just get a little bit of access. All of those things would be typical items that I bring along with me. Um,
Hmm.
I had to choose a favorite out of those. Probably the infrared camera would be, a winner in terms of the interesting information that you can sometimes gain. People often say, like, what can you see with an infrared camera? Do you see air leakage? Do you see moisture? Do you see thermal bridgings? Like, yes, but you can see it, but you have to catch it at the right time.
Yeah.
There is an entire season where an infrared camera will not tell you very much, which is beautiful weather where it's 70 degrees Fahrenheit inside and 70 degrees outside. Is like, leave the camera at home pretty much. Also, moisture. If the moisture problem has mostly, come to room temperature, you might not see anything in an infrared camera, for instance.
Mm,
You're on the evaporative cooling of that moisture to change and or the thermal mass of that water to basically make it show up as something different, a warm spot or a cold spot on an infrared camera. Can you see thermal bridging with infrared cameras? Sometimes yes, sometimes no. Like, if you're walking around the outside of a building, honestly, if it's during the day, the solar gain of the sun hitting the outside will overwhelm anything that you're trying to see on the outside. So pretty much next to pointless. So if
mhm.
you're trying to do a outward air leakage test or look for thermal bridging on the outside, middle of the night or the morning before the sun comes up, those are pretty much your only options,
Mhm.
unless it's thoroughly cold and thoroughly overcast, for instance.
Sometimes when I go to do inspections or blower door tests and we're using thermal imaging as a diagnostic tool, I'll ask the clients to put if it's cold outside, I'll say, could you put your heater on inside? Or if it's warm outside, I'll say, put your air conditioner on to just cool down some surfaces so we can see what's coming through.
Where you can. I've asked clients to do the same kind of things.
Mm-mm. Are you cut out there for a little bit, Coda? What did you just say? Sorry.
Oh, yeah. Like, I completely agree, and I've asked clients to do the same thing of bumping their thermostat up or down to give me
Yeah.
that delta T temperature difference inside to outside.
Yeah. 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 It's also something I recommend the building companies and site supervisors that we work with, I say just get a cheap thermal camera because you can easily, I mean, insulation is a good one. You don't have to have, you can have less of a temperature difference inside to outside when it comes to insulation, particularly in the roof, because that's very temperature sensitive. And it's a really good tool to, keeping the trades accountable to making sure that the insulation has been installed correctly. So I like the thermal camera too.
Absolutely. I was walking an attic recently where all the team had signed off thinking things were done, and I'm seeing all of these attic bats in the floor completely pulled back, just, leaving bare ceiling underneath them. But
Hmm.
that was nowhere near as convincing as walking into a room underneath that and showing, like, look at the patchwork quilt of all of these cold squares that I'm seeing in the ceiling.
Mm.
For heat that you paid for leaving your building.
Yeah, yeah. There's memes going around the internet with like there's bags of insulation sitting up in the ceiling, like unopened bags of insulation. There's insulation in the ceiling. It's up there.
One of my
Yeah.
colleagues have said, like, you might as well blow your insulation out into the parking lot rather than try to use it this way."
All right. So beer and building science, you have yourself and your colleagues have started this beer and building science forum where you get on the internet and you talk about building science over a beer. We have actually created one in Australia. There's a group called the Mindful Builder in Melbourne. And yeah, we kind of copied you after actually Brad from Sanford Build Co. Shout out if you're listening, Brad. He You met him here. You might have met him. I think he was at the symposium last year.
Okay, yeah.
Yeah, loved it. Came back, raved about it. Couldn't say enough good things about you specifically. He loved your talk about different tools. So this is why I'm asking this question actually about all the different tools you use and how to do it, concrete testing and all that sort of thing. So yeah, we started our own once a month. We catch up and a bunch of us talk about different topics. And what we're find like we share so much information amongst each other. We're trying to reduce the silos that we all work in. How effective do you think that your forum has been in doing this? And what kind of people attend? Is it mostly builders, mostly architects, mostly like who goes and how successfully is this information getting out there?
Oh, you're talking specifically about the Westford Symposium Building Science Summer Camp? Or
I'm talking about the beer and building science.
Oh, building science will do. So,
Yeah,
like,
it's
first of all, I
casual
definitely
chat.
want to make sure credit is where it's due. The full buildings, I am a contributor to occasional episodes of BS and Beer, but there's the solid team of,
Hmm.
Travis, Emily, Mike, Dan, the whole bunch that are the force that keep that moving forward. Hats off to them for
Fantastic.
bringing on so many great guests, putting out such great content, recording it on YouTube, keeping it for folks to hear. Like, it's on my to-do list to listen to the episode with my friend and colleague Henri Fennell, the rock star of spray foam, to make sure I get his little nuggets of wisdom, for instance. But your question was ultimately coming back to how successful is it as a format to keep
Yeah.
people out of their silos. Yeah, so yeah, building construction in general is a sadly siloed state of affairs in many times, in terms of the various trades talking to each other and then coming together as a cohesive whole. That big picture problem, I don't know if there's a great answer along those lines. We talk as much as we want to about the building as a system, but until you can get an electrician to seal the holes that he's punching through the air barrier, it's going to be an uphill struggle for sure. The BS and Beer guys have been doing a fantastic job of disseminating information, absolutely getting it out there. But, it's a bigger problem than them to break down silos, I think. But,
Mm.
the thing is, high performance architects and high performance builders do mesh together well, absolutely. And they are communicating relatively consistently. It's whether or not the spread to the wider building industry that I think is going to be the challenge.
Mm.
I don't have a great answer offhand.
Yeah. Yeah, I've often said that the problem, I mean, maybe this applies in all more industries than just the building industry, but it's often occurred to me that the solutions are not at a regulatory level. They're between those of us who get together and talk at places like the symposium or conferences and beer and building science and podcasts, and it's up to we come up with better ways to do things. And I like being part of that group.
Absolutely.
Yeah, people like yourself and Joe's website that you contribute to a lot. All of the presentations on there, the Build Show YouTube channel,
Absolutely.
all of the resources. That is where all of the good learning happens. The regulations are usually pitifully inadequate.
The regulations are probably multiple steps behind where the cutting edge of knowledge in the field is.
Mm.
Um, and also, just another data point is I've dealt with cases where I am dealing with techniques I have used for decades and going to another geographic location, and a builder says, I've never heard of it. And that kind of brings up that famous quote that the future is here, it's just not evenly distributed, is
Yeah. Yeah.
the industry.
Yep. Yep. For sure. All right. So let's talk about where this industry is going.
Yeah.
You've been around, you're part of the origin story at Building Science Corp. You were sort of around when building science kind of started to take off in America. You've seen a lot of change, probably created a lot of change. Where do you think things are going in terms of climate, carbon, resiliency, electricity versus gas, all of these key topics?
Yeah. So I am, so the big trends that are going around in North America, possibly smaller and only in pockets right now, are electrification and decarbonization of the building materials. Those are absolutely true. There are practitioners who are paying attention to that. Whether it gets larger traction, like I can easily imagine that in northern states, those things will take off. In Texas, 20 years from now, many people will still have not heard of it, frankly.
Mm.
Seems quite possible. There's a lot of different directions the industry goes in. In terms of other future trends, like people often push automation as a big item, and I'm going, it might, but whether or not it pays off is another question. Like in big commercial construction, that's the scale at which robotics does start to make sense. Like I saw this fantastic robot that looks kind of like a Roomba, where basically you set it down on the slab of your giant office building and it does your entire floor layout from the CAD plans just by having a printer that it's scooting along. And if somebody accidentally
Does
kicks
your
it does layout of all the studs, all the partitions, all of the plumbing lines, all
draws
where
it on
everything
the
draws it on the slab. Yeah.
Wow.
Yeah. I'll send the link for you sometime. But it was like,
Yeah.
that's an use of robotics that makes perfect sense rather than having guys with chalk lines and
Chalk,
laser
yeah.
levels. Is it 3'3" or 3'4"? Oh, crap. That kind of thing. Like, machine and let them do it. Or for that instance, like if you are sanding an entire 20-foot tall wall of drywall, they have those robots that do that kind of stuff. Whether it makes any sense in a residence, that's an like, I don't know whether that's adaptable or not. More power to them if they can make that work, but I wonder whether it can. The aerosol-based sealing methods. I don't know if you've seen those around or not.
Yeah, yes. I think Reclima's starting to come out with some of those.
Yeah, basically spraying an aerosol into the air, pressurizing your
I beg your pardon. No, different. That's different to what I was talking about. The aero barrier or aeroseal, is that the
yeah,
company?
aerosol
Seen
air
it.
barrier.
Looks
Yeah,
brilliant.
it's a fantastic
Mm.
technology, definitely costs, and
Yeah.
there are certain cases where it will work versus won't work, but
Mm.
that seems like a fantastic tool to add to the toolbox. If, just as a for instance, compartmentalizing multifamily buildings where you basically get each unit to the drywall roughed in state, with all your electrical rough in, seal all of the big holes, and basically do an entire floor at a time where folks are just moving their rig down unit by unit, having economies of scale. That would be incredible if they could get that to work, but
Mhm.
I'm not an economist, so I don't know how all of these bits and pieces come together.
Mm. Well, I'd be very interested to hear more about this little Roomba that sets out the layout. I will get that link off of you, and I'll put it in the show notes for anyone who wants to do a little bit more research into that and some other things we've talked about today as well. I'll put a few resources.
Yeah, absolutely. And I'm happy to put, as a side note, I'm happy to put some BSc resources on some of the topics we discussed.
Yeah, that'd be great. That'd be awesome. Okay, last question. I ask everybody the same question. What is the most important thing that you've learnt in your career? If you had one piece of advice for the audience, what would that be?
Wow. Yeah, I'm probably echoing many of your other guests who probably say the exact same rote thing, but staying curious, continuing to gain knowledge is pretty fundamental. That's like if you're not learning, you're stagnating. Like that's a pretty common sentiment, but it's,
Mhm.
very true. I know that the bottleneck for getting information into my head is not there's so much great information out there. Podcasts, YouTube videos,
Mhm.
web resources, articles. And I cannot keep up, frankly, but
I
I
know.
try to learn as much as I can. Like I get the issue of Journal of Light Construction or Fine Home Building in the US. The new article pops up on Green Building Advisor. The new video drops from the awesome framers. I try to catch wherever I can, but there's just so much that. And
And there really is. And we're all busy doing our day jobs and raising our families and having a life. But there is
exactly.
like when we've got a hungry brain, there's so much information I just wish I could pour it all in.
There's not enough time to get into digest all and to pull in all of that knowledge.
No, there isn't. There isn't, which is why I love my drives because I throw on a good podcast. And yeah, yeah. So I hope the person listening has done the same thing and has learned something today. Thank you so much, Kohta. It's been a pleasure to talk to you.
Jess, fantastic talking. Thank you so much for having me.
Thanks.
That is all for today. Thanks so much for tuning in. There will be another episode in a fortnight, so if you would like to listen into the types of conversations that I have all the time, please subscribe on your chosen platform. Rate the show, leave a comment, whatever you like, share with your friends and family. I'd love for you to spread the word about the Building Psychology Potty. There's a link in the episode description where you can head to a landing page, and there are some show notes there with relevant links and a full transcript of the show as well, and also links to my socials. So if you're not already, I'd love for you to follow along there too, as I share lots of building science and building biology tips. Thanks again. I'll be back in 2 weeks, so until then, happy healthy building.